Okay, so this lesson is going to be a little different. In this video, we're going to do a sort of speed run through the entire course curriculum. So we'll do everything from collecting our data, training our model, setting up an API, and then integrating it into our NoCode app step by step. So the format of this video would be more akin to what you'd be doing in the wild. If you sat down and you had a project and it's like, okay, what do I need to do? And we'll go through those steps in order. So once it's time to build an API, for example, we'll go to the documentation page for fastAPI and we'll adapt the source code that they have in the tutorial to what we need to do. So this is what you would do in reality. You'd consult the docs and adapt them to your use case. So that's what we'll do here. So this will be the structure of the lesson. First, we'll set up a development environment on AWS SageMaker. Then we'll collect our data, which will be a bunch of images. We'll train our image classification model, export that to deploy that model with an API using fastAPI, which is a Python framework. And then we'll integrate that API into our Bubble app. So this is the rough outline, which you'll see on the sidebar as well. And so let's get started. So the first thing to do is open up AWS SageMaker. So if we come to our browser, you log into Amazon or Amazon Web Services. This is the console homepage, and what we want to do is find SageMaker. So you can type it in here and you'll see it, or you can find it over here in machine learning. So SageMaker is the hosted Jupyter Lab, Jupyter Notebook service that Amazon offers. Let's type that in. We'll open SageMaker, and what this allows us to do is spin up or create hosted Jupyter notebooks, which we talked about in one of the other lessons. These are basically a test bench or development platform for machine learning engineers and data scientists. It's probably the most widely used tool for this kind of work, so really good to know. So what we do when we load this is we come into the notebook section, click notebook instances, and then we want to create a notebook instance. So what this will do is spin up a virtual machine or a computer in the cloud that we can use that has Jupyter Lab pre-installed in it. So let's type fastAI demo, or let's say speedrun 1. And so that's the name. I'll make this a little bigger. Whoops. That's the name of our instance or our notebook. Next, we want to select an instance type. And this is the underlying computer that will power our Jupyter Notebook or Jupyter Lab session. So what we want is the g4dn.xlarge. So this here is a particular type of EC2 instance, which we'll look at in just a second. It's basically a type of computer that Amazon will rent to you. And this is the cheapest GPU-powered server that we can rent that has an NVIDIA graphics card, which is something we won't go into too much, but makes it easier than using AMD graphics cards, because typically the libraries support NVIDIA a little better. It's a side note. Now note that you may not be able to select GPU-powered instances if you're new to AWS. There are quotas imposed on all of the different instance types that you can run. So if you don't have access to these ones, if you try to launch the notebook and you get an error saying that it's past your limits, then you can request a quota increase. If you type quota, you'll see this service quotas dashboard. You can open this and file a request for access to one of these instances. But we'll leave the details of that aside for just right now. We'll leave this alone, Elastic Inference, and for platform identifier, the default is this. The only difference between these two is the third one here is the more updated version of Jupyter Lab, so I'll pick that. We can leave this additional configuration as it is. If you have a large data set you think you'll be downloading, maybe increase the size of storage to 10 gigabytes or 20, depending on how much data you'll be downloading. The default of 5 is fine for us for right now. And then in here, it's going to ask you for an IAM role, which is sort of like a user role. If you don't have one that's already set up to allow access to SageMaker, then you can say create new role here, and then it will ask you what permissions you want to grant and so forth, and click create role, and then select that. And then the rest of this we'll just leave as it is, and we'll click create notebook instance. And after we click create, it will start to spin up an instance that we can use. This usually takes a few minutes, about 5 minutes. So we'll come back to this in a minute once this status changes from pending to in service. And you can see up here, that's what it tells you to do. So we'll just wait until that's there. So while we're waiting for this to spin up, actually, we'll take a look at some alternative platforms that you can use if you're not using AWS for some reason. So over here, I've got a few tabs open. So Paperspace and their Gradient product is a great platform. This is what the fastAI folks recommend in their course as one of the options you can use. So you can come over here to products, notebooks, and here you'll get sort of a breakdown of what they're offering. You can see here what their pricing is. They have a free tier, which can be great when you're starting out. You can see if you scroll down a little bit that they have free GPUs on the basic plan here, or the free plan. So that's a good option. Colab or Google Colab also has free GPUs. You can pay to get access to better ones, but by default there's some reasonably fast ones for free. Kaggle is another way to get access to free GPUs. So this is a data science competition platform. It's a great way to find data sets and find various solutions to machine learning problems. It's a great community. And if you sign in, you can use their kernels, they're called. They're basically hosted notebook servers, just like Colab and AWS. So these are three alternatives if for some reason you don't want to use SageMaker. So if we come back here, we see there's two instances that are, one's in service and one is pending. This was a mistake. I didn't select the right instance type when I launched this one. I'll delete this now. So we'll say stop, and we'll just delete it when it's stopped. And we want to actually launch this speedrun one, but it's still pending. So we'll wait another minute until this is in service. Okay, so a couple minutes later, we see that the speedrun instance is in service, and this one is stopped. So we're going to delete this one because we don't need this. So we can see here we have the option to open Jupyter or open Jupyter Lab. So Jupyter is just the notebook view, and Jupyter Lab is the notebook plus some other goodies. So I like Jupyter Lab. It gives you access to the file system in a graphical way and a terminal and stuff like that. And we'll look in a second at what that means. But they're the same project, sort of the same software package, but Jupyter Lab is just a bit more like an integrated development environment in some ways. So it takes a minute to launch, and once we get everything pop up, now we're ready to go. So the first thing we want to do when we load SageMaker is select a notebook kernel. So the kernel is sort of the Python install and the packages that come with that install that you want to launch. So if you look here, they all have conda underscore something. So this one here is conda underscore PyTorch underscore P38, so Python 3.8. This is the one we want, but notice this one here is MXNet. This one is Amazon EI or Elastic Inference. This is just a base Python install. This is TensorFlow and so forth. So you have the same sort of kernels down here if you want a terminal, but what we want, a Python console, and then you have your terminal down here. So what we want is the PyTorch one. So PyTorch is the deep learning framework that fastAI is built on top of. So when we launch this kernel, we have all the PyTorch libraries installed, which saves us the hassle of installing them, but they don't have fastAI installed. So the way to do that is in here, we can type shell commands or bash commands by starting our command with an exclamation mark, or what's sometimes called a bang in shell scripting. So if we say pip install, and then -- upgrade because we want to install the updated versions of the libraries, and then fastAI, fastbook. Then these two sets of libraries will give us the tools that we can use to train our model. So we'll install these, and this will take a minute, and then we'll come back when this is done. Okay, so now we're back, and these are all installed. This is the output from pip install, and if we shrink down, you can read it a little bit better. Note that down here at the bottom of the screen, it says idle. So after your command runs, you'll see that this shows idle, or this circle here won't be filled in. When you're running a command, this will be filled in, and this will say busy. So now we know that command is done. What we can do is clear that output, because we don't really need that on the screen. So right-click, clear output. Just before moving on, I want to fill in one gap. If you click here to launch a new notebook or terminal or whatever, and you see the same thing that we saw when we first launched it. I mentioned that these all have conda underscore, but I didn't explain what that was. Conda is a package management and installation management system for Python. So there are basically two programs that you can use to install libraries in Python. One is conda and one is pip. And you can use them together, but conda tends to be a bit more popular for data science and machine learning. So anyway, what it allows you to do is install a bunch of dependencies, and so conda underscore something means that's the framework they're using to install your libraries. So anyway, now that we've installed fastAI and fastbook, the next thing that we want to do is get some data. So what we'll do for that is we mentioned in a different part of the course that we're going to build a custom image downloader on Google Cloud Platform, but there's some utilities within fastAI that allow us to do that a little bit more easily. And these are mentioned in the first lesson of the most recently released version of the fastAI course. So if you come to course.fast.ai, then you will see this page here, and there's lots of resources. This is an incredible course, highly recommend. All of their courses have been amazing. Come to the first lesson over here, getting started, and here's the video for the lesson. And if you scroll down a little bit, give you some information about paper space gradient as we talked about in Kaggle. And if we scroll down a little further, there are links to some accompanying notebooks, Is It a Bird and Jupyter Notebook 101. So this Jupyter Notebook 101 helps you get familiar with Jupyter Lab, Jupyter Notebook. So it's helpful to learn how to use this tool a bit more. And in the Is It a Bird notebook, there's some code for downloading images and training models and so forth. So here he's using this download URL function from the fast download library, calling it here. And so this will go out to, I'm not sure if this is Bing or DuckDuckGo by default, but yeah, so he's downloading an image, and then here he's going to download a batch of images. So we're going to do something similar, but we're going to use something a little different. Instead of using these Kaggle notebooks, which we can close, we're going to use the lesson notebook. So if we open this link here, this will take us to the fastAI organization's course 22 repo. So course 22 is the 2022 version 5 fastAI course, and there are a bunch of notebooks in here. And so if we bring this one up, is it a bird? We'll see some code that he walks through, that Jeremy walks through in the video. If we scroll down a little, there's this search images function that he defines here, and this will go to DuckDuckGo and download images. So he's defining this function within this notebook, but in the FastBook repository, which is the accompanying repository for the fastAI book, which is here. Another fantastic resource. I strongly recommend getting a copy of this if you're serious about learning how to program in machine learning. And so that book is all built out of Jupyter notebooks, and one of the files that accompanies those notebooks is this utils file. And if we scroll down a bit, there's this search images Bing, search images DuckDuckGo or DDG. So you can call out to these two different search engines and automatically or programmatically download a batch of images. So we're going to use this one here, search images DDG. So what we can do is plug this into our code and download a batch of images. So the way that we do that is if we come back to our notebook, and from here we want to import fastbook, because remember this utils library came from the fastbook repo. So we say, or package I should say, so we say from fastbook import star. So this is an unusual pattern in Python. It's usually discouraged to do this. Basically when you import star, it imports everything in the package at the global level. So if we just said import fastbook, that's more standard. Or from fastbook import the specific function that we want to use. In any case, this is the way that they tend to do it in the fastAI courses, so we'll follow their conventions. And this usually takes a minute to import because it's importing quite a few libraries, so we'll come back when this is finished importing. Okay, so that import took about 3 minutes, and now we have all the fastbook tools available. Note that you can probably do this quicker by just importing the function that we want. So you could say from fastbook import search images DuckDuckGo. And this will run in a few seconds. Yeah, you can see that took about 12 seconds if we look at the elapsed time. So I'm not sure downstream if that will cause any issues without having the other functions imported. So we'll just use this kernel here. So then the next step is to use that function to download our batches of images. So let's get rid of these notebooks first of all. And if we come back to this utils file, we can see that the function search images DDG takes two arguments, a key and a max number of images returned. So we'll feed this one to test first of all, and then a key. So we're going to build a radiograph differentiator or radiograph identifier, which is going to be able to determine whether an uploaded photo is an X-ray or not. So we'll use radiograph for our first search term. So we click this to add a new code cell, and we want to say search images DDG. So this is the function name, and the key that we'll pass will be radiograph, and the number, max number of images will be 1, and then we'll say results equals this. So when we run this, we want to see the results. We can add results to the end, or we could have said print results. It's one of the nice things at Jupyter. You just type the name of the variable, and if it's the last thing in the cell, it will print it to the screen. So what the function returns, as we can see here, is that it returns a list of unique URLs of images. So if we were to click this and open it in the browser, it's going to be a PNG image. So we can download this, and then open it up. We can see here this is a lateral radiograph in a dog, I guess. So that worked. If we were to plug a photograph in here, do the same thing, and open this one up, then this is a photograph of a bridge. So we'll use photograph as our non-radiograph term. There'll be lots of variability in the data set that we pull down using photographs, so it should be enough to get us started at least. So because this function only returns a list of URLs, we're actually going to want a function to go and download these URLs and save them on disk. So if we come back to the course notebook, here we have, this is how they're setting up that search function, searching, and then there's this download URL function here in fast download. And that would probably work fine, but we're going to use this download images function instead. If we come back to our notebook and if we add a code cell and type download images, we can see what this is. Oops, lots of typos. We can see this is a function from the fastAI vision library. So this will just go out and download an image from the URL that we pass it. So let's cut this cell. And so what we're going to do is take this block of text and adapt it to what we're doing in our notebook. So we'll copy that, add a code cell, and paste it. So our searches are going to be radiograph and photographs. So we'll modify this, make this a bit bigger, and close this for now. And then our path will say radiograph or not. So this will be the folder or directory on disk. And then it says for O, or output and searches, set up a destination path and then make that directory. And if it already exists, that's fine. So it just doesn't fail if there's an existing directory with that name. And parents equals true means create the upper level directories if they don't exist. So if this path directory, which is this one here, if that doesn't exist, create that as well. And then we're going to call this download images function. And so dest will be whatever we create in these two lines. And then the URLs that we're going to create have to be generated from running that search images DuckDuckGo function. And here, this f string is saying take whatever the search term is. So radiograph will be the first one, and then add photo. We don't want photo on the end, so we'll just delete that. And we could just say replace this with O, and that will be the string radiograph or photograph. And then we're going to resize the images to be at maximum 400 pixels on each side. And if we were to run this now, by default, we would get 200 URLs for each search term. So that's the default max n argument is 200. So what we want to do instead is say for this URLs equals search images, we want to say 10 to start, just to test to make sure that everything's set up correctly. And then the other thing is this resize images function, when I ran it in test, was failing because it tries to save the image to the same place that it read it from. And I don't know if this is an operating system thing or a Jupyter thing or what, but basically what we want to do is change the output path to be something that includes the resized string in it. So what we could do is say, instead of path/o, let's say, we'll create this formatted string, this f string, we'll say path/resized/o. And so then we'll have a subdirectory called resize that will have all the resized images. And so if we run this now, we should get 10 for each term. Resize to maximum 400 by 400. If we open up our file viewer, we can see here we've got this resize directory. And so we can open up some of these images, and we can see they look good. And we'll check our radiograph one as well. So far, so good. We can see that we only have 4 results here, so often URLs no longer point to images. The image could be moved, or the link could be dead, or whatever. We'll deal with this again in a second pass in a minute to make sure that if we download broken images, we exclude those from our data set. But in this case, we had 6 missing images, and we just got 4 out of the 10. So we'll start with 200 and see if we have enough to build the data set from. So let's get rid of this 10. And before we run it again, we're going to delete this radiograph or not directory. And if we try to do it this way, if we say delete, we'll get this error message that it's not empty. So the way you can fix that is if you open a terminal window, come down to the bottom here, terminal, and then this is the home directory for this machine. We want to go to SageMaker, that's the user, and we can see that radiograph or not. If we say remove -rf, these flags will allow you to delete directories on Unix or Linux operating systems. We say that, and then we refresh over here, we see it's gone. So that's a little trick. So here we are ready to run this and get our 200 images back. So let's see if this works. Click enter or control enter, and we refresh. We should see radiograph or not, and it's getting our radiograph images. That's good. And then we'll get our photograph images. Oh, and then it has our resized images here, and so that's good. So far, so good. Now we see our photograph images, our originals, and we'll see photographs that are resized as well. And so that's all looking good. And we can see if we come over to this that our last function that we ran took 30 seconds. So in 30 seconds, we were able to download 400 images and resize them to a max size. And the reason that we resize these images is to make batching easier later. When we're training our model, we want to limit the size of our images to make it faster and to make them consistent. So that's good. So we've now got our 400 images. So what we're going to do now is set up our data classification model. So the way we're going to do that is we're going to come to the documentation for fastAI. So if you come to docs.fast.ai, you'll see this, and we want to reference the tutorial section under beginner vision tutorial. So we scroll down a little bit, we can see there are 3 main sections here. There's single label classification, which is what we're doing. We just want to assign 1 label to each image. Multi-label classification could be something like if you have, say, red shirts, red dresses, blue shirts, and blue dresses, how to assign both of those labels to each item, so what color it is and what kind of clothing it is, and then segmentation, which is identifying where certain objects are in an image. So anyway, what we're going to do is follow this cats versus dogs sample. And so here, the first thing they're doing is they're figuring out where the files are on disk, which is what we just did, sort of. And then they are creating an image data loaders. So this idea of a data loader in fastAI is how you bunch together your data and pass it off to your GPU or your CPU to train it. So this line here will say, grab all these images on disk and put them together in a bunch, and we're going to use that to feed it to our learner object next. So if we were to take this, this doesn't quite work for how we're set up right now. So this from name function is passing an argument, which is this label function, and it's telling the fastAI library how to appropriately assign a label. But as it says here, there are other factory methods on this image data loaders object, and the one that we want to use actually is called the from folder. So this is a slightly simpler setup. It just says use all the images in folder 1 as label 1, and folder 2 as label 2, and so forth. So if we scroll down just a little bit, we'll see the form here. The data loaders equals an image data loaders dot from folder, and here it's passing it a path. Now note that up here it says it creates a data set with train and valid subfolders. So if you've already separated your data into the data you want to train on and the data you want to validate on, which we'll talk about in a minute, then the data loader knows how to partition your data. But if you don't have that set up, which we don't, then you provide this valid PCT argument, validation percentage, basically. So what proportion of your data do you want to keep back for validating your model after you've trained? So we'll take this and then we'll modify it slightly. So we come back to our Jupyter notebook and we will open a new cell, or create a new cell, paste this in. Now our path is going to be the resized directory. So if we come here, we can right click on this and say copy path, and we can paste this in here within double quotes. Now this is a string and it's expecting a path object, which is a particular kind of object in Python from the path lib directory. So the way you do that is just wrap this in path, and so now instead of a string it will be a path object. And then we have to feed that valid PCT argument, and we'll say 0.2. So 20% of our data will be kept back as a validation set. So now if we run this, we should have a data loaders object that is has the two labels attached to the appropriate images and has our validation data kept aside. And we can inspect that by using this form here. We could say show us the first 3 items in the validation set, for example. So let's copy that. So we'll add a new cell under here, paste this in. Now we're just waiting for this data loaders call to complete. We can see it's been running for about 30 seconds, so it takes a little while. So skipping ahead in time a little bit, we can see that the elapsed time to run this data loaders creation was about 3 minutes, 172 seconds. So keep that in mind when you're doing this. Now we can inspect our data loaders and see that this is correctly formed, so it should be a path for each object, so that's good. Okay, so now that we can see that the paths are correctly formatted, another thing we could do is visualize the data with this data loaders.showBatch method. So if we copy this and put it into a new cell, we're actually going to see an error. So if we run this, what it's going to say is that some of the images aren't the same size. We scroll down here, it'll say that these 2 images are different size. The reason that's a problem is because when you're trying to load your images onto the GPU, they need to be the same size. So there's a way that we can fix that. We're going to have to backtrack a little bit, so let's clear this output. So what we're going to do is replace this step where we resize the images manually before creating our data loaders. We're going to get rid of this, and instead we're going to use the idea of an image transform, which is something built into fastAI. So when you create your image data loader, you can say that you want to apply this transform to every image and resize it specifically to, in this case, 224 pixels by 224 pixels. So we'll grab this expression here and come back to our Jupyter notebook, and we want to delete this resized directory because we're not going to use it anymore. So let's say radiograph are not resized. We don't want these images anymore. And so now when we call our data loaders function, we'll pass this image transforms argument, and then we'll bypass that issue with the differently sized images. So we'll run this again. Oh, and I forgot to remove this resized end here. So run this again, and now we should be able to see the same thing. So these are all good, and if we show batch now, hopefully it should work. But we see another error here, actually. So if we scroll down, it's saying it can't identify this image file. And so if we try to open this, this is the so 444D, etc. That's this image. We try to load it. We see it's an empty file or it's a corrupt file or something. So we missed another step, which is we want to validate that all of our images are, in fact, usable images. And there's another built-in function in fastAI that we can use to do that. So we can grab that by coming back to the first lesson in the course. And we can find that if we come back to the course notebook for lesson 1. We scroll down to step 2. It says here some photos might not download correctly. So what we want is this, this function here, this failed equals verify images. And basically what this will do is go through each image in the directory that we pass it. And then if it's not a correct image type, then it will delete it. And this path.unlink will delete that file. So let's grab this, come over here, clear this output, and let's say here, we'll say run this. So the path that we want to feed it, I don't know if we've set path yet. So path here is radiograph or not, so this should work. If we run this, and we can see 10 images were corrupted. And so now that we know that, we can come back, reconstruct our data loaders object. We could check this again if we wanted to, and then when we show batch, we should be able to see some images. And here they are, so we can see we've got some photographs, some radiographs. This photograph, interestingly, this is a black and white photograph, and all of the radiographs are black and white. So it will be interesting to see if this becomes a distractor or where the model fails, because that might be the most informative piece of information in this data set, is that radiographs are always black and white. And so we'll see as we get to training. Okay, so now that we have our data collected and organized into our data loaders object, we can now create our learner object. So there's a couple different ways that we can do that. If we come back to the docs, then there's this, this form. We could say learn equals vision learner. We pass it our data loader, the name of an architecture that we want to use, and then our metrics. And this is enough actually to define our learner. So we'll take this line here and create a new cell. Let's clear this out. We can leave that there, I suppose. Create a new cell underneath, close this. And we will run this and create our learner object. And you see when we run this that it will download the model that we want to use. So this ResNet34 is a pre-trained model. And what we're going to do is fine-tune the model on our data set. So this pre-trained ResNet34 model knows a whole bunch about the world because it was pre-trained on a large data set called ImageNet prior to this. And now we're just adjusting it to our specific use case. So the way that we do that is with this next line, where we say learn.finetune. So this fine-tune method will say train just on our specific data, but don't forget all the stuff you learned training on the previous data set on ImageNet. So we can paste this in here. So 1 might be enough. The number that goes in here is the number of epochs or the number of training cycles that you do. So we'll say 10, and we'll run this, and then we'll start to see our output for our model as it's training. It's going to show us how long it's taking and the error in each case. So it's going to train on the training set, which is 80% of the data. And then this 20% that we set aside here will be what it evaluates its accuracy against. So we'll let this run for a few minutes, and then we'll come back when it's done and look at it a little bit more. Okay, so now training is done. You can see that it took roughly a minute, took about 6 seconds per epoch, as well as this initial cycle took about 41 seconds. And you can see our error rate by the end is 0%. So we have a model that's 100% accurate at identifying radiographs after a couple of minutes. That's pretty impressive. So the next thing we might want to do is visualize some of our results. So if we come back here, whoops, not this one, we can see there's a learn.predict on specific files, which we'll be doing this later. But for now, let's grab this show results method, and we'll paste this underneath. If we do this, it'll show us the labels prediction as well as the true labels on the various elements in the data set. So for example, this is a radiograph, and it was predicted as a radiograph, photograph, and so forth. So that's good. So we now have a very accurate model. The next step is to take that model and export it out of this notebook and then turn it into an API. So that's what we'll do next. So in order to export our learner, so this learner object is our trained model, we can just say learn.export. You can find this if you come to the docs, the documentation for fastAI, and search for export. Then you'll see here that there's this, you can search on this page again for export, so learner.export. And it tells you the function signature here. It's going to create a file name, whatever you pass it. So this export.pickle is the default file name. PKL or pickle in Python is a data serialization protocol. So it's a way of basically of exporting data that you can then reload into a different program at a different time. So we just call learner.export, and it will create this export.pickle file. So if we do that now, we could go down to the bottom here. We could say learn.export, and Then if we open our File Explorer, come back here, it's probably in here, the path that we defined up above, which right here, that's going to be used by the export method to figure out where to save the file, or we can pass it a file name here. So we could say radiograph detector.pkl, just so that if we've saved other export.pickle files from fastAI, that it doesn't conflict. And then we will right-click and download this to our local computer, and then we're going to upload this to the computer that's hosting our API in the next step. So let's go back of this overview. We're done the first 3 steps here, setting up our development environment, collecting our data, and training our image classification model. The next step is to deploy a model as an API with fastAPI. So what we have to do here is we have to spin up a cloud server on AWS, on EC2 specifically, and then we're going to install the fastAPI library. We're going to set up a very basic API that will allow us to make requests to that machine and get responses back. So we're going to be uploading our file to that server. Whenever we make an API request, we're going to send an image to that server, ask for the prediction from our model that we just trained, and get back the response. So that'll be step 3, or actually step 4, but number 3 here on this list. So the 2 main steps of this is first to launch the server, and then to log into the server and install the packages that we need, specifically fastAPI and its dependencies, upload our model, and then set up the interface so that we can call this server. So let's go back to AWS. So here we're in SageMaker. We want to open EC2, which you can find if you type in EC2 here. So you can see virtual servers in the cloud. This is how we launch servers that we want to run. So we'll load this up. And this is the console. We can come into instances here, or we can click Launch Instance here. So click Launch Instance, and to run an API like this, you don't need a GPU-powered computer like we did for training. Usually a CPU is sufficient for inference, so we're going to use a very cheap and, in fact, free tier server. So if you're still on the free tier on AWS, you can use the T2 micro server by default. So let's say radiograph detector, and we're going to use Ubuntu as our operating system. This is just the most common Linux distribution, so everything tends to be pretty well supported. You can use Amazon Linux as well. It will probably work on any of these distributions, but we'll stick with Ubuntu because it's sort of ubiquitous. So we'll leave this default. We'll see T2 micro, so we can see here it's got 1 vCPU, 1 CPU, and 1 gig of memory. That's fine. Now, a key pair, you need a key pair to be able to log into the machine via SSH. So you can click here and you'll see some keys that you've previously created, or you can create a new one by clicking this. So let's say demo speedrun, and then you can tell it what kind of key pair type and key file format. We'll just click create pair, and it will allow us to download it. So here's our file. We're going to save it in the same directory that we saved our pickle file. And we want to allow SSH traffic so that we can log into the machine, and these 2 we can leave off. So these will open up ports 80 and 443 for traffic. If you were hosting a web server, for example, you might want these. We're not going to do that, so we'll just leave this for now. We're going to open up a port later to allow API requests, but we'll leave it alone for right now. So everything can be left default. Click launch, and this will just take a few seconds. Unlike when you are launching a notebook server, which might take up to 5 minutes, this usually only takes 10 seconds. With some of the more expensive types of machines, like with GPU-powered instances, for example, it tends to take longer. But here you'll see this switches from pending to in-service very quickly, or from pending to running, actually. Okay, so now it's running. That took about 20 seconds. The status check's still initializing, so we can log in, but some things might change. For example, you can't install packages right away when it's still initializing, but that's fine. So to log into this machine, there's a couple different things we could do. You could here say connect with this dropdown, and this will open in your browser. It will open a connection, an SSH connection that you can use to interact with the machine. And if you've never used SSH locally, this might be fine. This basically gets you into the server and you can start playing with it. That's fine. So what I'm going to do instead is I'm going to log in using a local SSH client installed in my Linux distribution. I'm going to open a local terminal window, and here I have SSH installed. And so the format to connect with the SSH command is this. So you say SSH-I for identity file, and this is the name of the file that I downloaded, demo-speed.en. So I made a typo there. And then you want to specify the username that you want to log in as, and by default Ubuntu is the username that an EC2 instance will launch as, and then the IP address of the instance. So if we come back here, we see this public IPv4 address. We want to copy this and paste that here. And so when we run this, I'm going to get an error. So it says you have this unprotected key file. And so this warning is saying that we have an unprotected private key file. It's saying this permissions is too open. This permissions level is too open. So if we list the directory contents, we can see here this is the permissions specification. So this RW is a 6, this is a 4, and this is a 4. I won't go too much into how Unix permissions work, but basically what you want is 0600, or this read and write only for the user that owns the file. So you can say change mode 0600, and this will only allow the current user or the owner of the file to read and write to this file. So we run this, and then if we connect again, then we won't get that error. So if we zoom out a bit, it says we're connected to our Ubuntu machine. So now we're into our server and we're ready to start working. So what we want to do next is we want to set up a Python environment and install fastAPI. So now the first thing I'm going to do is actually run a command called tmux, which is short for terminal multiplexer. This is a program that allows you to run multiple shells within a single window. So this is great if you want to have one window open to write your code and another one to, say, run your server or inspect the machine or whatever you might be doing. So you can see down at the bottom here that says 0 bash. So this is our first window. I'll open this top program, htop, just shows us what's going on with the machine. And then I'll create a new one, and I'll say new file.py just to show you that there are in fact multiple windows running, and then I can switch back and forth between these. So this is roughly what I'll be doing. So I'll quit out of this for a second and quit out of this. I'll just have the one window open for now. Now we want to go to the fastAPI documentation and look at how to install and use and configure fastAPI. So before hopping over to the docs, though, I'm going to turn on a program called ScreenKey, which will allow you to see what I'm pressing down here at the bottom, just because I'm going to be using some strange commands to work with Vim and tmux. And so if you're curious and you want to follow up, you can pay attention down here. Note that if you're not writing your code on the machine, on the server, typically what you do is you write locally and then you push that code up to somewhere like GitHub or GitLab, and then you pull it down onto your server. I like using Vim on the server because I can write my code there quickly. I don't have to worry about that sort of commit, upload, download cycle that you typically have if you're pushing code to some remote repository. So what we're going to do now is go back to the browser and we're going to find fastAPI. And so this is the homepage for this project. Now I'm going to close all these fastAI tabs for now. We'll zoom in a little bit. And so now this is an API building framework for Python. We can scroll down here. Lots of really great reviews and so forth. It shows you that the installation process is very simple. It's just pip install fastAPI, as well as uvicorn standard. So this is the server that fastAPI runs on top of. So we'll run this, these two commands, pip install fastAPI and uvicorn standard. So I'm going to copy this and come back to our server. Actually, before we run the installation, what we want to do is set up a Python virtual environment. So the way we do that is we say python 3-m ven. Okay, so it's not installed, so we say sudo apt install python 3.10-ven. And it looks like we mistyped this, python 3.10-ven. We did not. We want to do this. We want to say sudo apt update. Okay, so when I ran sudo apt update, I realized that the super keys the screen key being down at the bottom was blocking what I was typing. You tend to be working down here at the bottom in a terminal, so I just moved it up to the top. Okay, so now this apt update command basically says fetch a list of updated packages for this distribution, and now we should be able to install the virtual environment command. Now, the reason we're installing this is it allows us to create isolated sets of dependencies for our programs. So we create this virtual environment. I don't know if we need to restart either of these. I don't think so. I'm just going to click cancel. So now we can create a virtual environment here. So if we say python 3-m venv and then venv, we will have a new directory in our current directory, which we'll see here. Let's do this. Let's move this down here. So we can see this virtual environment directory. I'm going to make this bigger. So inside here we have a Python install and so forth, and we can say source venv activate, and we can see over here we now have this in parentheses. This shows us that the virtual environment is active, and so now we're ready to come back and install fastAPI. So pip install fastAPI and then this uvicorn standard. So we'll say pip install fastAPI and then uvicorn standard, and this will run for a second and install these packages. So while that's happening, we'll come back here. I think it's done already. Yeah. So now that it's installed, we can go on to the next step, which is here in First Steps, and we can take this here. This says the simplest fast API file could look like this. So this shows you to import the library, create an instance of the fastAPI server basically, and define a single method, so a get method on the root resource, and all it does is return this, this JSON object. So we'll copy this and we'll paste this into a file called main.py. So we come here, we say main.py, we can paste this in, and now if we save this and then we come back to the fastAPI page, we see here that this command here will launch the server. So we run this. What's happening here, so we get this error, command unicorn not found. That's because we didn't source our virtual environment. So we say source and bin activate again. So note that this only shows up in the terminal, in the shell, sorry, that you actually ran the command in. So now we should be able to say unicorn main app, copy it from up here. So basically what this is saying is look in the file called main for an object called app, which if we go back, that's this here, app, and we can see we're in main.py. So that's going to launch that. And this -- reload flag says anytime that main file changes, reload the server. That's fine. And so right now it's running on this port 8000 on this machine. So what you might be tempted to do now is to go and query this server, but it's not going to work because we haven't opened this port on our EC2 instance. So just to demonstrate, I'll show you what I mean. If we come back to our EC2 view, and we see here's our public address, we're going to copy this, and I'm going to open a program called Insomnia. So what this is a tool for testing APIs and various API endpoints. So we can create a new request by clicking this. We'll paste we'll say test fastAPI. So it's just the name of the test, and then we'll paste our URL in here. Now, if we query this, we're going to hit the root resource by default, but nothing is going to come back. It's just going to hang. However, if we go back and open port 8000, then this will run. So it turns out screen key is getting in the way quite a bit, so I'm going to turn it off. Maybe more of a nuisance for this kind of speedrun. So what we're going to do now is we'll go over to our EC2 instance, so back here in Amazon, and to open the port, what you want to do is come to security, the security tab, and there's this security group, which is created by default when you launch the instance, and we can see here's our security group rules. What you want to do is click on this security group and then come down here to edit inbound rules. And what we want to do is specify that a custom TCP rule on port 8000 and allow it to be accessed this 0.0.0.0/0. This means any computer address in the world. So we click Save Rules, and now that port will be open to any machine. So if we come back to Insomnia and now query, we'll see our request comes back. Oh, and I forgot one thing actually. So this actually won't complete until we, on the other side, within the server, if we specify that we want to open up the API to other machines. So just like we use 0.0.0.0 within the AWS console, here we're going to say that we want to open it up to the same, basically the same range. So if we pass host 0.0.0, so now it should be accessible from any computer on the internet. And so we've got our IP address. We also need to pass the port here, so colon and then port 8000. Maybe make this a little bit bigger. And when we run this, we get message hello world. So now if we go back to our server, if we were to change the message coming back, we could change the message coming back to say something like speedrun. We save it, we go back here, we notice that there was a change in main.py and it's reloading. And we come back here and we run this again and we say here message is speedrun. Okay, so that's all good. So the next thing to do is to import our model. So we're going to have to install the fastAI library in this server and then import it and then load our model. So let's do that next. So then our next step will be to shut down our server, and we'll get rid of this other window here. And we want to install fastAI. So we can say pip install fastAI, and this will run for a second and install everything that we need. And so while this is downloading, we can open our code up and start to work on that. So we'll say here, we also want to import fastAI. So we'll say from fastAI import star, as we saw in the Jupyter notebook. And then our next step will be to load our learner. So there's a method in fastAI called load learner, and we pass it the path of the file on disk. So we called it radiograph detector.pkl. Oops. Now we don't actually have this file on our server yet, so we'll do that in a second. we want to have it, if we specify it this way, we want to have it in the same directory as our Python file. So just leave this open for a second. Now, in order to get the file on the server, one way to do it is using SFTP, which is sort of like SSH. It's like a file, it stands for Secure File Transfer Protocol. So it opens up a shell session where you can transfer files. That's what we'll do. You can also use a command called SCP for Secure Copy. You can use PuTTY, I believe, on Windows. There's various different tools that you can use to connect and transfer files. So the way that we can do that is by using a command called SFTP, like this. So it's very similar to SSH. It uses the same syntax, except instead of SSH, we use SFTP. So we pass the same identity file to connect, and then we pass the username and address. And if we do this, we will connect to our machine, and we can see here the files that are on the machine. And locally, we can see that we have this radiograph detector.pkl file. So what we want to do is use the put command in SFTP to upload this radiograph detector.pkl file. You can see it's transferring at about a megasecond, but it's going to take about a minute or so. So I'll come back in just a second. Okay, so now we have our radiograph detector file on our server. I just want to backtrack briefly to correct two mistakes. So first of all, when I first installed the fastAI library like this, this actually errored out, and I didn't realize that it had. So this on this server, there's only about there's 1 gig of memory, and when you install it this way, there will be an out-of-memory error, and so pip will freeze, and fastAI wasn't actually installed. So what you want to do is run pip3 install with the no cache dir, like this flag, and this will stop you, if you're on a 1 gigabyte machine, this will stop you from having that error, so keep that in mind. And then the other thing is this syntax from fastAI import star. This actually won't work, so we want to replace this. We want to say import fastAI.learner, and so this gives us the module for the learner object. And so then down here, if we say fastAI.learner.loadLearner, we try to run this, then we'll see when we run this that we'll get this printout that describes it as a learner object. That should be right here. And so it's booting with no problem, so we're heading in the right direction. So now the next step is so this will load this into memory, so that's good. So it'll stay in memory while the API is running. The next thing that we want to do is figure out how we can test an image against that. So in order to do that, we need to allow the user to pass an image in the API. So by default, it just expects the API just expects a text string, a query. So what we want to do is change this to allow for files that are coming in. So the way that we're going to do that, if we come back to the fastAPI documentation, over here on the left, there's a section called request files. So if you click on this, it'll tell you how to set up your API to accept files. So the first thing here is that we need to install this pip install Python multipart. So you can copy this and paste it into a terminal. So let's say we open a new one, we source, then bin activate. We can then run pip install Python multipart. I've already installed it, so it'll just say requirement already satisfied, but that will give you this library that you need. And it says it's because our files are sent as form data, which we'll see in a minute. And then we need to change our import line from what we had before. So initially we had from fastAPI import fastAPI. We want this instead so that we can deal with these file and upload file objects. And come back again. And so it says here now we need to define our file parameters. So we basically just need to specify the name of the file. So they have two demo functions here. So this one where there's a file is a bytes object, and then this file upload file, we're going to use this syntax here. You scroll down here. You may have noticed in the fastAPI docs that they highlight the line that they're talking about in the next block of text. So this is really handy to sort of follow as they build stuff up. So we'll take this and we'll paste this into our file. Go down to the bottom, and so this sets up a new method, a post method on our API at /upload file, and it's expecting a file object, and it will just return the name of the file that we send. So if we save this, our API will reload. We see it's reloading here, and it's reloaded successfully. So what we'll do now is we'll come back to Insomnia and we'll create a new request. So we'll say new request, and this will say upload file. This will be the endpoint. So then we need our address of our machine. So if we come back to AWS, I had to reboot the machine earlier as a result of that no cache dir missing that argument. So we'll copy this IP address, paste it in here. We want port 8000, and the endpoint is upload file. And now if we send here, it'll fail, method not allowed. So this has to be a post. And our body, instead of a no body, we'll set it to multipart form, as we saw in the fastAPI docs. And then here, our file will be the name of the field, and then the value, we're going to change this to a file object. So we click here, and we can pick any file object and send it over. And if we pop back to our server, we can see it's processing, and then we get a response here, file name 2.gif. Okay, so that's good. So now what we need to do is actually test this image file against our model. So let's do that. So in order to do that, we need to do a couple of things. First of all, we have this file object in memory, but what we need to do is save it to disk and then pass it to our learner object. It's expecting a path on disk. So what we'll do is we will write that to disk, that file, and then we'll pass it to our learner object. So that looks like this. First, we'll say that contents, or the file contents, equals await file.read. And so this method will read the contents into memory. And then we'll say with open, and then we need to give it a file name. So let's just say test.png. And then we need to give it a flag here to tell it what mode to open it in. We want to open it in write binary mode. And then we say as f, so it's going to open it. The file object will be called f. And we want to say f.write contents. And so now the contents of this file that we uploaded will be saved on disk at this file location, test.png. And so now we can exit this with block. This is called the context manager. We can exit this, and we can say that our prediction is our learner object.predict, and then we pass it the name of that file. So test.png, like so, and that's our prediction. And so we could print our prediction out, for example, and we can also return it. So we can change this here, realign this. We'll say return prediction. Now if we come back to our server, we see it's restarted, so that's good with no error. And if we come back to here and send it again, we should get a prediction response instead of the file name. And here it says photograph. So it predicted photograph. This means we've got everything wired up correctly, which is great. Now, in addition to returning just the label, you might want to return the probability of, or the confidence of the model as well. So the way that you can do that is if we run a prediction, right now if we upload, we'll see we get this photograph string back, that's fine. But here, where we're printing out this line here, where we print the prediction, we can see that we get the label here in the first slot of this tuple. This is a 3-element tuple here that we get back from that predict method. The second element is the category. So category 0 is the first category. And then here is the probabilities for each category. So for category 0, which the model thinks it is, it's 9.9999 e to the negative 1. So it's 99.999% confident that it belongs to this category. So you might want to return that as well. So the way that you could do that is instead of just returning this prediction element, you could say result equals, and then we'll create a dictionary, and we'll say maybe category. And that will be prediction, the first slot of prediction, so prediction 0. And then we'll say probability. And so then at that index, at index 2, so the third element here, we actually want to take this 0th element, so we pass that here. We say prediction 1. And so now we're saying whatever this number is, get us that index within this object. So this is a little bit tricky to read. You could say something like index equals prediction 1, and then here we would just say reference at the index. That's the same thing. It's just a little bit cleaner to read maybe. So now we should get the category and the probability of that category back. So if we, instead of returning prediction, if we return result and save it, we'll make sure that our model gets loaded correctly and the application starts up. And now we come over here, and if we run this again, we should now get a dictionary with a label, so category is photograph, and probability is empty. That's because I forgot something. So if we come back here, we notice that this tensor base, fastAPI doesn't know what to do with this by default. So we need to manually convert this value to a float. So a floating point number is just like a decimal number, sort of. So we'll do that, we'll reload. And once this reloads again, we can run the same query and hopefully get back our probability as a decimal number. So there it is, 99.999, etc. Okay, so that's our API. It's deployed, and we're ready to plug it into our application now. Okay, so now that our API is ready to go, at least minimally, we're going to pop back to our browser, and I've logged in here to bubble.io, and we're going to click Create a New App, and this will take a second. It's going to ask for some details. So we'll say, call it speedrun. Start from a template, no, marketplace. So what kind of app are you building? So this stuff doesn't really matter. It's to help Bubble figure out sort of what to show you and to gather some data to help their users. But we'll say SaaS, software as a service, we'll say it's internal. Our goal is to say test out a business idea, and let's just say speedrun. This is optional, so I guess we can leave this alone, and we'll say create a new app. Speedrun is taken, so let's say speedrun launchable. Now we'll create a new app. This will take a second, and when it's ready, it'll pop us into the editor. Okay, so now the app is loaded. It's going to ask us, there's an assistant to sort of walk through getting set up. We can just close this. We'll have a blank page. And so the first thing we want to do is integrate our API. So if we come over to plugins and add plugin, what we want to do is add this API connector plugin and say install. So now it's in here. We want to add another API, and we'll call it radiograph detection. We'll say that. We're going to use it as an action so that we can trigger it in a workflow. The data type that we're going to be getting back will be JSON, so this is fine. It's going to be a post method, and then in here we're going to paste the address, and then the address that we want here we can get from our Insomnia client. So we grab this and come back. Now if we paste this in, this won't work for two reasons. First of all, we need HTTP on the end here from the beginning. We have to be explicit in Bubble about that. And then here, if we send it like this, it's actually going to fail. And the reason for that is if we come back to our server, we can see here that the method that, the route that this API is listening to is /upload file and then a slash on the end. So we can take that slash off, or we can just add it here and it will resolve correctly. We just need to make sure that it maps correctly. Then the body type we want to set to form data. By default, it'll be JSON, but we want multi-part form data, so let's change that. We'll say add parameters. The one parameter that we need is file, and then the value, we click this send file box and it will give us an option to upload a file. So we'll say, I'll pick this picture of anime characters, and it'll upload it. And then once it's uploaded to the Bubble file storage, we can then send it off to our API. I'll just take a second. And now that it's uploaded, we want to uncheck this private box because we're going to want to make this dynamic in a minute. So we click initialize call, and this should return to us the same JSON that we saw from Insomnia. So here we go. We have our category of photograph with this probability. So we can test another one. Click save to instantiate that. And so that's good. That means that our API is now integrated with our Bubble app. So we can quickly build a mock interface. If we say we want to add a picture uploader to our page, so we'll say picture uploader. And when the user clicks on this to upload an image, so let's say click uploader to classify image. So I'll just add this. So I won't go into too much detail about styling and stuff. We'll get into that in some of the later lessons, but we'll say here that when the value of this changes, that we call our API, and then we set the text down here. So let's set the value of this to be on the page. We'll create a custom state. We'll call it result. And that will be text, and so I suppose we could do, yeah, so that'll be text. And then we'll say that this text, we'll make it an H2, let's say. H2 heading dark, we'll make this H1, just for a little bit of differentiation. And we'll say click uploader to classify image. This is quite large as H1. We'll say that when this changes, so we'll say, we can say start edit workflow here. So when the value is changed, what we want to do is call our speedrun plugin, and the file that we'll send is this uploader's value. So that'll be the image. And then when we get the result back, we're going to set this state that we set, this custom state here. We're going to set that to whatever the category was that we got back. So we'll say set state of an element. Element we'll set as index. The result value will be whatever the result of step one's category is. So what we could, instead of just having a result, we could say category and probability. So let's say prob. This will be a number. And so what we'll do instead is we'll say set the category to the results category and set the probability to result of step one's probability. And then here we'll duplicate this, and this one will display category like this, and then we'll add indexes category, and then here we'll say probability is equal to, oops, try that again, probability is equal to the indexes probability. So this will give us our results. Let's test this out and see if this works. So we can say click to upload an image. We've got this anime heroes image again. So we'll upload this, and then when this finishes, we should see these two category and prob elements update. So let's see what happens. And we can see actually here we have this .. ellipsis, so we didn't make the text elements large enough. we'll fix that in a second. If we click on it with inspect, we can see that the text actually does say category photograph. But if we come back here and just make this wider, whoops, just make it extra wide so that there's room, and we'll just rerun that inference again, just to show. And now that it's done, you can see we've got the category photograph with the probability here. So then just one last thing we'll say here is if you want to start to store the results of these inferences in your database, you come into your data tab, go to data types, we'll click image, we could type radiograph inference or something, we'll just call it image, click create, and it's going to need an image, so we'll call this image, and we'll set it to type image, we'll set a category, whoops, and this will be the text value, and then we can say here we want the probability, and what we'll do is when we set these values on the UI, we'll also create an entry in our database. So we'll say create a new thing of type image. We can say add all fields here. The image will be this picture uploader's value, the category will be the result of step 1's category, and the probability will be result of step 1's probability. So we save all this in the database, and then something we could do is we could show the user the ones that they've uploaded already. So let's add a repeating group here. Let's say not a fixed number of rows and columns, and we'll say they're 100 by 100. It will be of type image. We'll say do a search for image. We'll just grab all of the images for now, and then in here we'll put a little image, and the value here will be this current cell's image. So the image is the data type, so it might be a bit confusing if we have the same name for a field and the value. So let's just say inferenced image. This isn't quite, this doesn't really make a lot of sense, but we'll do this. And then let's maybe make these cells a little bit larger. We'll make them 200 by 200. And then below the image, we can say display the category and the probability. So here we'll say current cell's inferenced images category. So maybe like this, we'll say cat : space. And then underneath, we'll say prob, and instead of category, it will be probability. And now, if we run this again, then we should see underneath, we should see the ones that we've already run. So let's do this one. And now that that's done, I'll just upload a few more, and you can see sort of down below what it looks like. And so now we've uploaded a few more, and you can see 100% accurate with the uploads. So we have a radiograph, photograph, radiograph, radiograph. This is a duplicate, but radiograph, and photograph, photograph, photograph. So we can see that pretty quickly we're able to train a model that can do this, build an API, and then deploy it to integrate with a NoCode app. So good luck, and feel free to reach out to myself or the other students in the class if you get stuck, and excited to see what you're going to build.